We're going to talk about how to find an oblique or slanted asymptote in this video. An oblique slanted asymptote takes the form y equals ax plus b. Does that look familiar? Doesn't it just look like the slope-intercept form y equals mx plus b? Yep, that's right. A rational function has an oblique asymptote when the degree of the polynomial in the numerator is exactly one value greater than the degree in the denominator. So it'd be like if we had x to the fourth divided by x to the third. See how the 4 is 1 bigger than the 3 exponent? We can find the equation of the oblique asymptote by using long division of polynomials. Now there'll be a link in this video's description to take you to Algebra 2, 6.4a and 6.4b. This is long division of polynomials and monomials, and this is polynomials to polynomials, okay? So that one might be more helpful. We divide the denominator of the rational function into the numerator and use the first two terms in the quotient. We ignore the remainders. And these two terms will be the ax plus b part of the equation of the oblique asymptote. So, it's really, really important that you know how to do long division of polynomials before you start doing this. Otherwise, you're going to be totally lost. So, you can click and watch these two videos to get a quick refresher or to learn how to do it. So here we've got this rational function. We can see the 4 is 1 bigger than the 3. So we're going to have to do long division of a polynomial. So here's our problem right here. We've got this numerator divided by that denominator. See that? The first thing we're going to do is the first terms. How many times does x to the third fit into x to the fourth? 1. We just have an x. And x to the third times x is going to be x to the fourth. We subtract it. And 3x times x gives us 3x squared. And this negative 1 times x gives us a negative 1x. We do our subtraction. And now we've got a negative 3x to the third. How many times does x to the third go into this? Negative 3 times. And then we do our multiplication again. Here's 3x times negative 3 is a negative 9x. Negative 1 times negative 3 is a positive 3. And because we only need the first two terms of the quotient without remainders, that's really all we needed. The oblique asymptote is y equals x minus 3, the first two terms in the quotient. Without the remainder, we ignore the remainder. An oblique asymptote creates two new possibilities for the graph of our rational function. If a function has an oblique asymptote, its curve tends to be a very flat-looking C on opposite sides of the intersection of the oblique asymptote and a vertical asymptote, or the curve has U-shapes between the asymptotes. So let's take a look at these two graphs. Here's a vertical asymptote of x equals 1 coming down this way. All right, let me get a little closer for you. See how this is our vertical asymptote in this dark yellow? And the oblique one is where y equals x minus 1. See? We can draw the curves. They come close to the lines, but they never touch it. And now we've got our hyperbola, don't we? Here's where the vertical asymptote is x equals 1, and our oblique one is y equals x plus 1. So you can see how it went up. See how this one is down here? It's coming through here below the origin. Now our intersection is up here above the origin, isn't it? So we have our hyperbola. It's a very C shape, isn't it? It's very curved, where this one's more open. See that? So it has an oblique asymptote. Its curve tends to be a very flat-looking C. See that? For the hyperbola. Now you can click on this video's description and there's going to be a link to the vertical asymptotes, the horizontal asymptotes, and those two videos on dividing polynomials. Okay? Remember, the asymptotes are imaginary lines that a curve gets closer and closer to but never touches, and they're lines drawn to help us with the shape and direction of the curve of the function, and they show where the function isn't. So they're guidelines, aren't they? So For this oblique and this vertical one, it says, well, it's going to come along here and go down, but it's not going to go on the other side of it, is it? This is the guideline for it, all right? I hope this was helpful, and I hope you're doing well. I'm really proud of you for watching these math videos to help yourself. That's a very good sign of good character. I'll see you next time. Bye.